Okay, so just looking at the last part now, which is obviously we're going to talk about the distal convoluted tubule, which obviously behaves in a similar way to the proximal convoluted tubule, but mainly focusing on the reabsorption of water, which, as we know, is under the control of ADH, antidiuretic hormone, that's released from the hypothalamus and secreted from the pituitary gland into the bloodstream, where it can come down and it can act on receptors on the epithelial cells, and those receptors are found on the cells of the distal convoluted tubule and, of course, of the collecting duct. And I'm not going to, because the cell looks a bit small up at the distal convoluted tubule, I'm not going to say too much about it up there. But the principle of aquaporin channels is the same for both cells. So first of all, I should probably just go back and mention how the distal works. So again, active transport of sodium ions, any remaining sodium ions that are in the filtrate can be actively transported out, which means they can move down their concentration gradient. And so sodium ions just being an example of that. So on to the final reabsorption of water then. So this is just the fine tuning. So obviously a lot of water has already been reabsorbed, both in to be fair, we didn't even talk about it in the proximal convoluted tubule, but it can be reabsorbed there as well. A fair bit is reabsorbed there. Clearly, we talked about the loop of Henle in the previous video, and a lot of water is reabsorbed there, as are sodium ions. And then lastly, we can look at the fine tuning based on our environmental conditions, or basically whether we've got enough water or not, and that's the role of ADH. So as you can see, hopefully, that you can see down here, the ADH has travelled in the bloodstream and it's bound onto its receptor on the epithelial cell membrane. When that receptor has been activated by binding, it can activate the enzyme phosphorylase. And we don't have to know anything more about this mechanism other than the fact that phosphorylase, when it's activated, is able to cause these vesicles, which contain aquaporin transmembrane proteins in their membrane, to fuse with the epithelial cell membrane on the filtrate side and insert the protein, the aquaporin protein, into the cell membrane of the epithelial cell so that it is open to the collecting duct. That means, of course, that water can be reabsorbed. And by putting more channels there, you can get more or less reabsorption. Of course, it continues to move into the bloodstream by osmosis. So by using ADH, we can fine-tune water reabsorption. And as you would have seen from the previous lesson, where we've talked all about that, this is how our body can respond to different amounts of water. So if we're very dehydrated and we want to conserve our water, there'll be osmoreceptors will detect that, and clearly we don't want to be inserting we do want to be inserting more aquaporin channels. So our brain, the osmoreceptors, release ADH, that moves into the bloodstream, causes this cascade of reactions, resulting in more aquaporin channels and therefore more water to be reabsorbed and therefore conserved. The urine therefore would be very concentrated. So conversely, if we're well hydrated, then the osmoreceptors will not shrink, they'll be swollen, and then that won't release as much ADH, and therefore we won't get as many aquaporin channels inserted, and therefore less water is reabsorbed, and our urine would be more diluted.